This is review problem number 6 for assessment number 7. If a person with weight W bends at the waist with a straight back, then the force F exerted by the lower back muscles may be approximated using F equals this equation, 2.89 W sine theta plus 90 degrees, where theta is the angle between a person's torso and the horizontal. Approximate the value of theta that will cause a 150-pound person's back muscles to exert a force of 100 pounds. So essentially what they're asking you in this problem is, we want you to find theta. So we want you to find theta that will cause this person that's 150 pounds to exert a force of 100 pounds on their back muscles when they bend over. So just imagine like stretching your hamstrings, all right? Keeping a straight back as you bend over, you're essentially putting some stress on your back muscles, and this equation represents the force that you're putting on those back muscles as you bend over and create different angles. Now the problem, they give you this whole story problem, all this context for a problem that's actually pretty easy, because they tell you the force. They tell you the force is. Well, they tell you the weight. Sorry, the weight is 150 pounds. They tell you the force is 100 pounds, and they just want you to find the angle. So let's just plug those in. We get 100 equals 2.89 times 150 sine theta plus 90 degrees. Now you should notice in this problem that sine theta plus 90 degrees, I have an angle plus another angle. That's a sum and difference formula. So let's go ahead and look at our sum and difference formulas here and see that we have a sine addition formula. So I can actually expand this out by writing sine theta cosine 90 plus cosine theta sine 90. So let's go ahead and do that. We get 100 equals 2.89 times 150. And then I'll say that this is times sine theta cosine 90, remember that's a multiplication, plus cosine theta sine 90. Now if we look, we know that cosine 90 on the unit circle, if you look at cosine 90, that'd be 0. So cosine 90 up here is 0, which cancels out this term. We know sine 90 on the unit circle is 1. So we end up with just cosine theta. So if we rewrite this, we can say that this is 100 equals 2.89 times 150. And then we just, that cancels. This is 1, so we're left with cosine theta. And that all came from just using the sum and difference formula, the sine sum formula. So now we're looking for theta, so we're just going to divide 2.89 and 150 to this side. We get 100 over 2.89 times 150 equals cosine theta. Now if you want to, you can put this in your calculator. And I'll have 100 divided by 2.89, make sure you put the denominator in parentheses, times 150. I get 0.23068. So this is 0.23068 equals cosine of theta. Now I want to take the inverse of each side to get theta by itself. So I'm going to take the inverse of the left side, and the inverse of the right side. Take the inverse of the right side, the cosine inverse and the cosine cancel, you're left with theta equals whatever this answer is. Well, let's type in cosine inverse of that. So we do second cosine inverse, second answer. Tells us that our angle is 76.6 and I don't know what they'll have you round to, but we'll go 76.66 degrees. Obviously, just round it to whatever decimal place that they tell you in the problem.